Good day everyone, my name is Xiang and today I'm going to present my final year project and the title is Ontology-based Medical History Management System. Okay, so let's get started. So there's a total of around 550,000 traffic accidents happened in 2018 and 1.1% of them involve deaths, results in 150 accidents per day. And the failure to retrieve an injured person past medical history has increased the rate of fatal. So before the first aid of stabilization is applied to the injured person, it's dangerous because the medical history of the person remains ambiguous and the patient might be allergic to certain medicine. Currently, we are lacking of a centralized system to store people's medical history. And also the transportation of injuries to the accident and emergency or NE department takes time, and it might be too late when the condition of the injuries is to be analyzed after reaching the hospital. Therefore, I propose to develop a system that utilizes a medical ontology from the Wikidata, which allows users to perform create, retrieve, and update operation in order to manage people's medical history. Besides, a real-time communication between paramedics and NE unit physician can be done through the system. So what is Wikidata? Wikidata is a free and open knowledge base that can be read and edited by both humans and machines. And the knowledge is in the form of ontology, and it can be curated using the Sparkle query language. So the medical ontology will provide the related information of a disease that is helpful for the medical person. Okay, so this is a heart disease. One of the example I screenshot from the Wikidata, and it has the description of the disease, the drug or therapy used for treatment, the symptoms and signs, and so on. So here are only a few attributes of the disease, and there are more in the medical ontology. Okay, so why we are choosing Wikidata and ontology? Wikidata contains near to 100 million items, and it is very flexible biomedical semantic knowledge base. It has the potential to perform a much better role as a large-scale biomedical semantic resource. And by using the ontology, we can infer a lot of information that is useful to a medical person without storing a lot of data in our database. The methodology used in this project is Agile methodology, as it supports incremental and continuous iteration of development and testing. It's also very flexible and allows implementing regression testing. Okay, so this is the phase of chosen methodology. During sprint 1, the requirements are being gathered, and then the system is being designed. After that, the user module is being implemented, following by the emergency module and also the medical record management module. And during the last sprint, the overall testing has been carried out. Okay, so the technology used during the development of the system, for the front end, I'm using Angular framework. The back end, I'm using the Firebase cloud function, while I'm using the Firestore for the database. For the requirement elicitation, since there's a lack of the stakeholder, so the requirements are elicited from the general paper provided by Xiang, which is his road accident management, and also from two of the existing systems now, which are from the OSP labs and also the Henry Schein MicroMD. The general paper and the existing systems are researched, compared, and analyzed to get the requirements of the system. So these are the use cases of our user module. As you can see, there are 4 users here, which are the system admin, the paramedic, the medical receptionist, and also the NA unit physician. So all of the users can perform the login use case, and the system admin can register user and also manage the user. For the emergency module, the actors included are the paramedic and also the physician. Both of them can search for person and they can view the medical history of person, while the paramedic is able to send injuries detail, and the send injuries detail can be viewed by the physician. As for the medical record management module, the medical receptionist is included in the use cases of this module. They can also search for person and view the person's medical history. They can also update the person's medical history as well as insert new medical record for the person. For the non-functional requirement, we have our security. So since the user have to log in before using the system, here is our user authorization and also our user roles restriction, which means certain types of user can only access certain pages and perform certain functionality. And also we have our portability here, which means our web application can be used by different type of web browsers and is available to our user most of the time. And also, since we are using the Angular framework, we are reusing our component so that our code is easier to be managed, created, modified, and updated at ease. This is our component model, and we are using the MVC, which is the model, view, and controller architecture. And as you can see, the modules are grouped into their respective M, V, and C package. Okay, so this is our class model here. We have our user parent class, and the medical receptionist primarily and any unit physician inherit from the user, and all of the user can access the medical record, and medical record will have the medical record detail inside it. And this medical record belongs to person, and the person will also have their allergy record. And also, if there's an injured person, the person will have their injuries detail, and the injuries detail can be sent by the paramedic and to be viewed by the physician. Okay, so here's our ontology design, and we can see we have our disease here, and these three are the selected attributes of the disease, which are the symptoms and signs, the description, and also the drug or therapy used for treatment. And here's our example used, which is the heart disease. Heart disease is an instance of disease, and these are the instance of symptoms and signs, while these are the instance of drug or therapy used for treatment. Okay, now we are looking into the implementation and testing phase, where there are four main development included. So the first one is the basic code development, the interface code development, the ontology query development, and also the database query development. Okay, so here is our basic code development, and we have two of our screenshot of code segments here. On the left side is the TypeScript part of our Angular component. For the right side is our code segment of our Firebase cloud function. Moving on to the interface code development, this is the HTML code, and also its correspond CSS code where we use to develop our web application. And the ontology query development, we are using the Sparkle language where we send HTTP requests to our Wikidata. And here is the sample of the data returned from the Wikidata. Well, for the database query development, this is our query written, and we are using this query to ask for data from the Firestore. And here are the example of data returned from the Firestore. Okay, and now we will talk about the user acceptance testing, or UAT. So the participant of our UAT is an IT official from IT department of Hospital Sultanah Aminah, and it's carried out on the 7th of May on 10:30 a.m. via Zoom meeting. And the participant was handed instruction manual for our ontology-based medical history management system, and several data was collected during and after the testing, which are the demographic, the time taken of every task, and also the satisfaction of testing using the system usability scale, or SUS. So there are 4 steps for our UAT. So the first step will be filling the demographic questionnaire, and after that, the participant will carry out the 9 tasks design, and we'll collect the feedback from the participant. On the last step, the participant is required to fill in our system usability scale questionnaire. And here's our UAT result, where we get a best imaginable score for our UAT, which means our participant is very satisfied with the system we developed. And as a conclusion, all the objectives have been achieved, where we are able to identify and implement suitable medical ontology to retrieve information on diseases, and we are able to implement the system using the selected framework, which is the Angular, and we are able to validate and test the system for performance and correctness. However, there are some suggestions for future improvement, where the usage of bioinformatics, such as fingerprint or face recognition, can be implemented into the system to identify the injured person's identity instead of using their name or their IC. And also, the usage of ontology to store medical record will be more feasible, since we are talking about storing all the medical records of the citizens of Malaysia. So the data will be huge and complex. And hopefully, after some research has been done, we are able to host our ontology online and be accessed via a web application. So that's all from my presentation. Thank you.